record. There we go. Okay, should be recording now. And so I was a little bit delayed in getting the material up for you guys, well, for all my classes, because we spent all weekend at Cal Poly San Luis Obispo with the academic quadrathlon team who represented Chico State really, really well. I'm very proud of them. So if you guys see Manny Lopez or Marissa Budesilich, Luz Morales, or Nicole Fornicari around, they were the AQ team this year, and they did a really great job. We got home really late on Saturday night, so still trying to recover from that. All right. So since we are kind of in week number 10 and really focusing through, oh my gosh, people are way late this morning. It's driving me nuts. And are pushing into the luteal phase. I want to do just a couple of other poll everywhere questions from the follicular phase, so from chapter 8 last week. So let's go ahead and get this up and going. And so our next question is, what stages of the estrous cycle are in the follicular phase? So starting out just kind of at the very beginning of the follicular phase. So we'll give you guys 30 seconds here. All right, 5 seconds to go here, guys. So what stages of the estrous cycle are in the follicular phase? Go ahead and submit those last responses. I'm going to lock them in. All right, let's see where we're at. Okay, good. Good. For the most part, we're on track. So the follicular phase is made up of two major stages. So the proestrus and the estrus stage are going to make up the follicular phase. And so keep in mind, proestrus is where we see the shift in hormonal concentration. So that's where progesterone is going to decrease and estradiol is going to increase. And then estrus is when estradiol is so high in the circulatory system that it becomes the dominant hormone in the inventory at that point. And so during the estrus phase is a pretty short phase, usually within about anywhere from 18 to 30 hours, depending on species. But that is when the female is going to be receptive to a male. All right, so again, good job, guys. So proestrus and estrus make up the follicular phase. All right, let's go to our next question here. Get activated. All right, so what hormone must decrease in concentration in order for a selected follicle to become dominant? All right, so, let me put it, we'll go back to there. All right, so 30 seconds here, guys. So what hormone must decrease in concentration in order for a selected follicle to become dominant? All right, 10 more seconds here, guys. All right, let's go ahead and lock those answers in. All right, so we're kind of all over the place, but the majority of you guys definitely got the correct answer. So progesterone. Progesterone is the one that actually has to decrease in concentration in order for a selected follicle to become dominant. So let's look at this really quickly. This is the best one. So, Gabby, you're the only one that I can see. Can you just give me a thumbs up? Are you guys seeing the PowerPoint? Okay, good. Thank you. No, not okay. Let me reshare. All right. Okay, we should be there now. All right, so this question has to do with this chart here. So last week, we very briefly talked about the follicular waves that occur on the ovary of the female. All right, so we're going to have follicular waves occurring all of the time, continuously, once that female has entered puberty. So the way that those follicles actually can become dominant is only when progesterone actually decreases enough to allow that dominant follicle to again get bigger, receive more FSH, produce more estradiol, and then more estradiol is going to be in the system feeding back to the hypothalamus, which will initiate that surge of GnRH and then a subsequent surge of LH, and that LH surge is then going to result in ovulation. So the correct answer to this question is progesterone. So progesterone is the hormone that has to decrease in order for a dominant follicle to become the primary structure on the ovary and to eventually move towards ovulation. All right, so what we see when progesterone is high is even if we have a dominant follicle on the ovary, because progesterone is high, that is indicating that the timing is not correct for ovulation to actually take place and for a pregnancy to have the highest chance of implanting in the uterus. And the reason for that is because the timing of the cycle is completely off. The hormones are all going to be messed up. So what ends up happening when progesterone is high is that dominant follicle actually will die. It will go into atresia, noted as A here. And so the only time that we do not see that dominant follicle die is when progesterone is low. All right, so just give me a thumbs up, guys, if this is making sense at this point. So do we have a good understanding that progesterone has to decrease in order for the dominant or for the follicle to become dominant? Okay, I'm seeing a handful of yeses and thumbs up. Great. All right, let's go back to poll everywhere again. I've got one or two more questions for you guys. All right, so next question. Which of the events below must occur first in the follicular phase? Is it ovulation, follicular preparation for ovulation, gonadotropin release from the anterior pituitary, or sexual receptivity on the part of the female? So which of these events must occur first in the follicular phase? All right, we'll take 30 seconds here. All right, 5 seconds to go. Let's go ahead and lock our answers in. All right, so let's see what we got here. All right, kind of all over the board. Okay, so we've got some things to kind of talk through here. So the end of the follicular phase is going to be signified by ovulation. So that is like the fourth event that actually takes place here. Ovulation is way, way, way down the list. All right, so there has to be a whole bunch of things that need to occur first in order for ovulation to actually occur. And so the first one is that we actually have to see a release of gonadotropins, so LH and FSH, from the anterior pituitary gland. Specifically, we're actually looking for that flood of LH or that LH surge coming from the anterior pituitary gland that serves as the pre-ovulatory LH surge. All right, and so when LH actually hits the system, it is going to do a variety of things. And so let's look at what some of those things actually are. All right, so this slide here really gives us an overview of what is happening after.
Casey, we can't see your slide.
Oh, I'm sorry. I thought I chose the right thing. Thank you. There we go. All right. Hopefully we're looking at a PowerPoint of a whole bunch of arrows right now. So with the pre-ovulatory surge, folks, that is going to be coming from the anterior pituitary gland. So prior to this point, we have been getting mixed or a variety of signals back to the hypothalamus. And the hypothalamus, which houses the GnRH neurons, is going to be the major regulator and puppet master of the reproductive system. So with GnRH, keep in mind that this cyclic female is really producing the hormone GnRH in massive quantities, and it's being stored in GnRH neurons. And so we're seeing that GnRH actually be produced in response to increasing estradiol. So estradiol is coming from the dominant follicle that's on the ovary, and it is feeding back to one of its target tissues, which is the hypothalamus. And so we're seeing estradiol go up and up and up, and that is starting to create that threshold effect in the hypothalamus that we've been talking about. And in response to increasing estradiol levels, GnRH neurons are producing and then storing a lot of GnRH in the neurons. So when estradiol gets to its maximum amount coming off of the ovary, that sets the threshold and signals to the GnRH neuron, hey, we are ready for something to change in the cycle. So GnRH will be released from the surge center. So we get that surge of GnRH. It travels to the through the adenohypophyseal portal system, a very short distance to the anterior pituitary gland. And in the anterior pituitary gland, the GnRH neuron is actually going to bind to gonadotrope cells in the AP. And these gonadotrope cells are going to be producing a large amount of FSH and specifically LH here in this instance. And so that is what we are talking about with the LH surge. So there's a large amount of luteinizing hormone that is getting dumped into the blood system from the anterior pituitary, and it is headed to the gonad, specifically the ovary in the female. And so when this pre-ovulatory LH surge goes to the ovary, we get a ton of things that start to happen. So one of the things is that histamine is upregulated. And so histamine is just like our immune system. So when we're like having trouble with allergies and everything else, because there's so much histamine in the air, it's kind of the same thing. So histamine is going to be upregulated, and it's going to help with growth of the follicle and hyperemia. Okay, so kind of swelling and major growth or to the follicle. And so also that pre-ovulatory LH surge is going to upregulate PGE2, which is going to increase blood flow to the ovary and specifically the dominant follicle. And that actually creates this edemic response or the swelling of the dominant follicle. The LH surge is also going to upregulate PGF2 alpha in the ovary. Okay, and so there we see contraction of the smooth muscle tissue, and we also see PGF2 alpha releasing enzymes, specifically lysosomal enzymes. Okay, so lysosomal here is really important because this type of enzyme actually will start to cut other proteins up. It lyses it, it starts to kill it. Okay, and so those other proteins are going to be proteins that create the wall of the follicle. And so we see a weakening follicular wall in response to PGF2 alpha. But we also see the LH, the pre-ovulatory LH surge shift the production of estradiol, which was coming out in massive quantities off the dominant follicle, to progesterone. All right, so this shift to progesterone will actually stimulate another enzyme called collagenase. And collagenase, in addition to these lysosomal enzymes that were triggered by PGF2 alpha, work together to weaken the follicular wall. So they're chewing up collagen, they're chewing up smooth muscle cells, they're weakening it. And so what ends up actually causing a lot of, or causing the ovulation event is a combination of this increased follicular pressure plus a weak follicular wall. And then we get ovulation occurring. So the pre-ovulatory LH surge is just what is the first event in a massive chain of events that occur. So this is where my comment last week about ovulation being a process and not necessarily just an on-off switch is coming to fruition. So there's lots of things that are contributing to the process of ovulation here. So I just wanted to go over that because that previous question on Poll Everywhere about which of the events must occur in the follicular phase first. In order for all of that downstream effect to occur, we have to have LH, the LH gonadotropin, released from the anterior pituitary. All right, so that is where we really start that whole entire journey. All right, so I've got one last Poll Everywhere question for you. So let's go there. All right, so let's go back to instructions, go to this guy and get activated. All right, so in an effect of the pre-ovulatory LH surge is an increased blood flow to the ovary and the dominant follicle. What hormone directly causes this to occur? All right, so we'll take 20 or 30 seconds there as well. And we just talked about it. All right, 10 seconds to go. All right, let's go ahead and lock them in, guys. Okay, so the correct answer here is PGE2. All right, so let's go back to what we were just looking at. All right, so here is PGE2. All right, so just as a review, PGE2 is being upregulated by that pre-ovulatory LH surge. And it is actually increasing blood flow to the ovary and the dominant follicle. So we're getting down to some really intricate detail here. Okay, so I asked you in that question, what hormone increased blood flow to the ovary and the dominant follicle? So we have multiple things happening here with ovulation. And so we're increasing blood flow. We are actually creating lots of pressure in the follicle. And at the same time, we're starting to see some of those lysosomal enzymes and collagenase weakening the wall. So there's lots of things that have to take place in order for ovulation to take place. So I just wanted you to focus specifically on what PGE2 was doing in its major role here. And we don't talk about PGE2 very often, but it has a very, very important role in ovulation. All right. Any major questions about the follicular phase? I would love to just answer any questions you guys have. We'll just take a minute here and let you think through them. Feel free to just speak up or put them in the chat. All right. Not seeing anything pop up, so you guys must have a really good handle on it. So let's switch gears and do a quick announcement first, and then we'll get into chapter 9, which is all about the luteal phase really quickly. All right, guys, so I want to share an opportunity that we actually have created for you guys. And so this, if you guys are interested in becoming certified in artificial insemination, the AltaCal Genetics Group, which is a semen company, they specialize primarily in dairy genetics. They have agreed to actually do an AI school for us up here in the North State. And so the AI school will be Friday, April 22nd through Sunday, the 24th. So about 3 weeks away. And the 22nd, it will actually be at the University Farm in classroom 107 and start at 1 p.m. And so that day is very much going to be dedicated to some classroom instruction and some track work. And then on Saturday and Sunday, the 23rd and 24th, respectively, you guys will actually meet out at the Alves Dairy that is in between Willows and Orland. And it'll take you about 30 minutes to get out there. And so you guys can carpool together, take a lunch, snacks, that type of thing. And you will actually be in cows. So one of the dairy folks out there is donating a bunch of his cull cows for you guys to actually practice on and get certified on. So you're going to spend 2 days in dairy cows. And so if this is an opportunity that sounds really interesting to you, I will send this flyer out to the class through an email. And so the cost of this is $400, and which is still about $200 cheaper than anywhere else you're going to find it. And we're very grateful that Alta kind of stepped up and took the lead on this, because Dr. Doyle and I usually like to teach AI school, but with the cost of cows right now, the cost of feed, the cost of fuel, and limited time, we were not going to be able to pull it off. So Alta Genetics stepped up and said that they would do it, which is great. And so if you guys have any questions, I can try to answer them for you. The key here is first and foremost to get signed up. And there's some, you can call or text or email and to get signed up. And then they will take care of all the money and stuff on the 22nd during the first day. So any questions about AI school? All right. So let me see if I can actually just put this in the chat. File. Open. As desktop. Okay, maybe not. Okay, sorry, I'm gonna have to just send it out on email. I can't get that link to work. Okay, luteal phase, chapter 9. Okay, so Tate put in the chat, heard they were only accepting 20 students and there have already been 15 signed up. Yes, so they're actually going to take up to 25. So there's an extra 10 spots available, which is why we kicked it to repro. So definitely jump on this sooner rather than later, guys. Thanks, Tate. All right. Okay, guys, so with the luteal phase, we are really looking at the second part of the estrus cycle here. And so with the luteal phase, there's going to be 3 major events that take place during this phase. The first event that has to occur is the process of luteinization. And luteinization is where we see the CL, or the corpus luteum, actually form. Okay, so that CL is going to be coming from the follicle that just previously ovulated in the follicular phase. And so that CL is actually going to do a pretty amazing transformation. It's going to utilize the same cells that were in the follicular phase, but they are going to get their second job instructions, and they're going to start producing progesterone here. The second major event that occurs in the luteal phase is the synthesis and then the secretion of progesterone from that CL. So that is going to be the longest piece of the luteal phase, where we see continuous synthesis and secretion of the steroid progesterone being secreted out of that CL into the blood system to various target tissues, which we'll cover in just a second. And then the last event of the luteal phase is the termination event. It's called luteolysis. So this is where the CL is lysed or killed. And so with that event, we see progesterone decrease and that dominant follicle actually increase, which is similar to what we just talked about with the follicular wave question on Poll Everywhere. All right, so let's take a more focused look at step number 1 here, the luteinization process, or the formation of the CL. All All right, so over the next series of slides, you guys are actually going to see this graph, and we're just going to build onto it. So let me orient you to what's going on here. Down here on the x-axis is the days of the estrus cycle. Okay, so we can see that the met estrus stage of the luteal phase is really taking place right after ovulation, up to about 5 to 6 days after ovulation occurs. That is met estrus. And then from that point on, from about day 5.5 up to day 18 or 19, depending on what species we're talking about, is going to be the longest stage of the estrus cycle, diestrus. All right, so we've got about 10 to 12 days of being in diestrus during that phase. So that's what's happening here on the x-axis, is we're looking at the days of the estrus cycle. On the y-axis over here, we're looking at progesterone concentration. So the hormone progesterone and how concentrated it is in the blood level. All right, so our first event is going to be the luteinization process, where we are, what is actually happening on the ovary is that follicle has just ovulated and has pushed us into the luteal phase, specifically met estrus. So during the met estrus stage of the cycle is when that CL is going to form. All right, so that luteinization process is really occurring during these 5.5 to 6 days after ovulation. After the CL and the luteinization process has occurred, we are then going to see progesterone increase in secretion. All right, so it's going to take a few days for that really traumatic follicular ovulatory event to heal up enough and to transition those cells from producing estradiol into producing progesterone. However, after about 3 days, we'll start to see progesterone increase. And once progesterone becomes the primary hormone in the blood circulatory system, from a reproductive standpoint, then that actually will shift into diestrus, where progesterone will remain high until the very end of diestrus. And so that ending part is really a step 3 here, where we see lysing of the CL occur. So lysing of the CL is actually caused by PGF2 alpha that is coming from the uterus. And PGF2 alpha at this point is being produced in response to an absence of pregnancy in the uterus. So the uterus is waiting and waiting and waiting during this diestrus phase here in the hopes that a fertilized embryo is going to attach somewhere in the uterus. And when that doesn't occur, then the uterus is like, hey, there's no pregnancy here. Let's produce prostaglandin F2 alpha and kill the CL so that we can start the cycle completely over again. And so that signal is what will kill the CL on the ovary. And with that, we will see a massive decrease in progesterone, like over a day to 2 days. And that is the luteolysis process, is that killing of the CL and the shutting down of progesterone. And that will take us to the end of the luteal phase and back to the beginning of the follicular phase, specifically proestrus. And so as we see progesterone just dropping like a rock here in proestrus, you would also see estradiol starting to rise here to start through the estrus or the proestrus and the estrus cycle. So that's what is going on from a hormone standpoint. And with the luteal phase, progesterone is going to be one of the main hormones involved here. All right, so with the process of luteinization, so going back to that first event in luteolysis, what is occurring here on the ovary is that the theca interna and the granulosa cells that were associated with the follicle are actually transforming after ovulation. So here's the thecal cells are the little ones, the granulosa cells are the bigger ones. After ovulation has occurred, we get mixing of these two cell types. So that basement membrane that we talked about in the follicular phase is gone. So we get a mixing of these cells here, and they are actually transitioning into small and large luteal cells. All right, so the large luteal cells are going to produce progesterone and the small luteal cells are going to produce progesterone. So in the follicular phase prior to this, the large luteal cells were actually granulosa cells that produced estradiol, and the small luteal cells were theca cells that produced testosterone. All right, and so as we go through ovulation and these cells actually get new instructions and their new job orders, they are both producing progesterone. So that's one of the reasons that progesterone will remain really high for a really long time, is because now we have two cell types that are actually producing progesterone. All right, so these small luteal cells here are going to be mixed in with these large luteal cells, and you can see the artery system. Both the veins and the capillary beds are very intricately woven in between all of these cells, so that it is a very quick transition from the time progesterone is produced in one of these cells to the time that it diffuses across the membrane into the blood system. All right, so that's one of the reasons that we can see a pretty fast increase of just a couple of days of progesterone, is because the blood system, the delivery system, is right next to those cells. All right, so let's talk really quickly about progesterone targets. So this is something that you guys studied in chapter 5. I told you everything from chapter 5 on is always going to come back to chapter 5, the hormones. Okay, so progesterone is a steroid. All right, and we know that because progesterone ends in ONE, right? So progesterone, along with the other two steroids, testosterone and estradiol, are going to be derived from cholesterol. So keep that in mind, because that's going to become really important. All right, so progesterone, once it is secreted into the blood system from the CL, its target tissue is first going to be the hypothalamus, okay? And when progesterone feeds back to the hypothalamus, it's actually creating a block to the GnRH neurons. So we call that negative feedback. So progesterone negatively feeds back to the hypothalamus. And so what this means is that it is blocking GnRH from actually being produced in massive quantity. All right, so we just went through a major massive event and production of GnRH that resulted in ovulation in that pre-ovulatory LH surge. So now the whole system needs to reset, and progesterone is the key hormone that makes that happen, because it creates that block on the hypothalamus. A second target of progesterone is the uterus. So the uterus is going to be really close to that ovary, and specifically the CL. So progesterone doesn't have to travel too far to get to the uterus, but progesterone is going to be affecting the myometrial layer of the uterus as well as the endometrium, and it has two different effects here. So at the myometrium level, that is the smooth muscle layer, we see progesterone reduce all of the contractions that were previously occurring because estradiol was high in the system. But since we transformed that follicle into a CL, we switched the hormones that it was producing, the myometrium really can just relax now. So those contractions have been reduced. So really quickly, guys, just to make sure that we're all on the same page here, I want you to talk to me for just a second. So with that reduction of contractions that is occurring in the uterus, what are we hoping happens because of that environment that progesterone has created? What are we hoping is happening right now in this system? So if progesterone is high and is reducing contractions in the uterus, making it a warm, fuzzy environment, what are we hoping is going to happen in the uterus?
That without contractions, the embryo can attach.
Exactly, Katie. Thank you so much for participating. Yes, you're absolutely right. So prior to this, we had that follicle that ovulated, right? And so we're going to get more, we're going to learn a lot more about fertilization in chapter 12. And so what actually is occurring there is that egg from the follicle is being caught by the infundibulum and being shuffled down into the ampulla isthmus junction of the oviduct and is hopefully been fertilized at this point, right? And so what it is going to do if it's been fertilized is it's going to go back down the uterine horn into the uterine body. And while progesterone is creating this nice, really calm environment, we are hoping that that embryo is going to attach. All right, so, and we are hoping that we get a pregnancy. All right, so I just want to make sure that we are really connecting the hormones and the concentration and everything that is complicated and happening there with what the hope of the whole system is. All right, so let's go back to this. All right, so the target of progesterone in the uterus is going to reduce contractions at the myometrial level. And then at the endometrial level, this is where the glands are, where all the hormones are going to be produced. A lot of those really essential proteins and secretions that provide nutrition to the embryo and everything, is we will actually see incremental endometrial secretions, where we are getting secretions that are going to support the development of the conceptus. Okay, so even that conceptus or that embryo, while it is floating around the uterus waiting to attach, it has to eat, it has to grow. All right, so it's going to get a lot of its nutrients from that endometrial layer. And so that is going to be another function of progesterone on the endometrial layer in the uterus. And then finally, the last major target of progesterone during this part of the cycle is the mammary gland. And so we don't see final alveolar development occur until the very end of pregnancy, but we will see progesterone actually start this process during diestrus. All right, so there we go. Okay, from a brain standpoint or a hypothalamus standpoint, I just want to make sure that we're all on the same page that GnRH is actually serving as an inhibitor, or not GnRH, sorry, progesterone is serving as an inhibitor to GnRH. And so that inhibition process does a few things. So it first reduces GnRH pulse frequency, okay, and then it's going to prevent behavioral estrus from taking place so that female is not out roaming around searching for a male. Is also going to stop the pre-ovulatory LH surge from happening so that we don't get subsequent surges in a messed up hormonal cycle. And then finally, it is also going to reduce myometrial tone. All right, so this happens in all species except the mare. The mare is weird. All right, so we actually need myometrial tone through the next estrus cycle in order for the conceptus in the mare to actually attach. All right. Oh, come on. There we go. So that's what this looks like from graphic standpoint, so again, we're getting progesterone that is produced here in the corpus luteum to feed back negatively to the hypothalamus, feedback positively to the alveolus, and then feedback positively to the endometrium, but negatively to the myometrium. So the negative effect of the myometrium is the calming of those smooth muscle contractions. All right, so just as a really quick reminder, progesterone is going to be produced from cholesterol. And so up here in this sequence, this is something you guys have seen before from chapter 5, where we start with cholesterol and then it goes through several enzymatic conversions and clippings to actually get down to progesterone, testosterone, or estradiol. So at this point in time, we are actually working with progesterone. All right. So when progesterone is being produced in those small and large luteal cells, what ends up occurring is cholesterol, shown here as LDL cholesterol, is actually accepted into the cell and then esterified. And so that esterification process is where the receptor is going to leave the cell and cholesterol is going to remain inside the cell. So at this point in time, in the small and large luteal cells, they've got a lot of cholesterol already in their cells, but the signal for them to start cleaving cholesterol down to progesterone occurs when LH actually binds to its receptor, which is signified as LHR here. And that kicks off that secondary messenger system where we get upregulation of the G protein, upregulation of adenylene cyclase, and then we actually get production of cyclic AMP, and then subsequent production of protein kinase that will actually mediate the process of this event. So protein kinase has to be high in order to accept cholesterol into the cell and for the cholesterol to esterify and for cholesterol to actually be converted into pregnenolone here in the mitochondria. All right, and so what ends up occurring is we get that conversion process from cholesterol to pregnenolone, and then pregnenolone will go out of the cell into progesterone. And that progesterone is what is being produced from the small and large luteal cells in the corpus luteum and feeding back to the hypothalamus, the uterus, and the mammary system. All right, and then I know we are getting short on time, so the last process of this is luteolysis. And so luteolysis is where we actually kill the CL. And it's going to do that by recognizing that there is no attached pregnancy in the uterus. What ends up occurring is we actually will start to see oxytocin receptors on the endometrial cells. And then we will see a critical level of oxytocin produced by large luteal cells in response to an absence of pregnancy in the uterus. And that production of oxytocin then triggers PGF2 alpha to be synthesized by the endometrium. And so as we are approaching day 15, 16, 17, 18, down here towards the end of the cycle, the uterus is very aware that there's no pregnancy in place. And so more oxytocin receptors are going to be created in those tissues. And then in response to that, we get more oxytocin binding to its receptor. And we get PGF2 alpha being produced in very specific spikes. And so the amplitude of these spikes are going to be very high. And that is what triggers luteolysis to occur, a decrease in P4 to take place. And so we define this whole time frame here at the end of the estrous cycle as luteolysis. So where we start seeing an increase in PGF2 alpha and an increase in oxytocin receptors. All right, and so what happens with PGF2 alpha on the corpus luteum cell on the ovary is we get binding actually occurring here of PGF2 alpha to its receptor. That opens a calcium channel. Calcium ions flood into the cell, and that is where we start getting apoptosis taking place. So it's two separate things happening because PGF2 alpha is binding here. We're getting apoptosis to happen and actual lysing of the cell to occur, but we're also seeing the PGF2 alpha shut down the conversion of cholesterol to progesterone. So two events are occurring when PGF2 alpha binds to its receptor on the CL. All right, so those are just a really quick look at the three major events that are occurring during the luteal phase. So luteinization is the first one, production of progesterone is the second one that is going to its target tissues, and the third one is lysing of the CL or luteolysis. All right, guys, thank you so much for being here today. I will get this up on Blackboard as a recording. In the meantime, I will hang out for a couple more minutes and answer any questions that you may have.
Thank you.
You're welcome. Thank you.
Thank you. Have a great day.
You as well, Daphne. Thanks.
Thank you.
I just had a quick question. Do you have any do you know any places that I guess offer volunteers? Because I grew up in a city, so I don't have like a lot of experience working with farm animals, and I would love to get some. I did
Awesome.
actually see, I was at the festival over in Oroville, and I saw like a booth where it was, I guess, women in the beef industry. And it was funny, I talked to them and they and they knew you, and I was like, oh my God, that's my teacher. And they said that you might have more information on
Yeah,
that possibly.
absolutely. Yeah. So you probably saw the Cattle Women's booth.
Yes, that's what it was.
Yeah, yeah. So they're a great group of ladies. They represent the county, and their whole mission is like beef promotion and education. So they do scholarships every year. They do workshops. They go to those type of events and just try to share information about beef cattle production. So that's great. I'm so happy that you were able to connect with them. As far as like getting experience, I'm assuming since you went to Oroville, are you living in Chico?
Yeah.
Okay, cool. So I always have to check because some students haven't moved back yet. So what I would suggest is maybe looking into one of the Animal Science 199 opportunities for the fall. So that is what we call an apprenticeship, and you can do that at any one of the livestock units. So dairy, beef, swine, sheep, and the meat slab. And so my suggestion would be to kind of pick one of those, contact the faculty advisor for those units, and they will let you know kind of what their process is. So for like us at the beef unit, we really only have room for 3 people in the fall because we just aren't that busy. But we usually take on 5 or 6 people during the spring.
Oh, okay.
Yeah. And then, but the dairy, they take 5 both times of the year, I think.
Okay.
So yeah, and so that's what I would suggest. If you haven't been around a lot of large animals before and their size kind of scares you, then definitely check out the swine unit with Mr. Carlson or the sheep unit with Dr. Phillips.
Okay, cool beans. Do you know of any places that I know it's like I tried like running around maybe some like equine ranches, and not a lot of them have, I guess it is probably because of like insurance and stuff, but
Yeah.
I know it's kind of like a long stretch. Do you know any that might have any volunteering opportunities? by chance?
Oh, I do not.
That's okay. I know it's hard to find
Yeah,
any.
the equine side is a little bit tough. What
Yeah.
you may want to do is, what is there was a,
I know
oh,
there's like a ranch down, it's like in Durham, and I can't think of the name, like Camelot.
yeah, Camelot. Um, that what you may want to do is just instead of getting like direct or direct experience with horses, you may look into stall cleaner positions or
Okay.
yeah, something like that that would put you around horses and definitely build some respect for horses and that type of thing, but
Mhm.
isn't directly like related to horses, if that makes sense.
Okay. Cool beans.
Yeah, so check with Camelot. There's also a boarding facility kind of around Upper Park area too, off of Bruce Road. Is it Bruce? Yeah, I think it is Bruce Road. And so you may just check in there as well. And
Okay.
then Almond Tree boarding facility is actually on the way to the farm if you go the back way.
Okay.
Yeah, and so right before you turn onto Hagen, if you look to the right, back to the west, you'll see like an arena and stables and that type of thing. So you might just, try to contact them and see if they're hiring or something like that.
Okay. Awesome. Thank you so much.
You're welcome. Thanks, Bailey.
No problem.
All right, bye-bye.
Bye.